Welcome to Guide Mia. Today we're going to talk about using orthoplus, walking your first clear aligner case end to end, from raw intraoral scans to a safe project and an uploadable deliverable. This one is for the designer who already has orthoplus activated on a workstation and now wants to actually drive it. Load scans on data preparation, repair them, segment teeth, finalize the tooth setup, stage the movements, add attachments, generate the design output, and hand the finished work back to Cympha. Budget a generous first session. The first walkthrough is really about learning the pages. Cases go much faster once you know where everything lives. Follow along at your workstation, or listen now and read the written guide later. Let's begin. What you need on the bench. orthoplus installed and activated on a Windows workstation. The Setup AlignerBot guide covers the subscription, the activation code, 10 minutes, one machine, and the installer. This lecture assumes the main window is already open. An upper and a lower arch scan, stone model digitizations, and intraoral scans are both first-class inputs. And recommended an additional bite scan. For severe malocclusion, you can mount models on an articulator. Physically or virtually, scan at a different bite position, register upper and lower to it, and plan on the newly articulated jaws. And if this case is a Cympha AlignerBot assignment, open it from the case folder the agent manager downloaded and keep your outputs there. The agent watches that folder, and that's how deliverables upload back to the case automatically. First, the shape of the software. orthoplus is not a locked linear wizard. The workflow toolbar carries named pages you can jump between at will, data preparation, case data processing, tooth segmentation, tooth alignment, planning final positions, movement planning, aligner design, aligner or model design, bracket bonding guide design, case restart, and reporting. You're free to move around. Refix a mesh after segmenting. Revisit staging after seeing the attachments. This walkthrough follows the natural order for a first aligner case, roughly left to right along the toolbar. Prepare the data, repair, segment, plan the setup, stage, place attachments, generate the output, save. Learn it once in this order, and the toolbar becomes a map instead of a mystery. Before the manual walkthrough, one button deserves its own moment. The toolbar also carries an AlignerBot button, the automatic treatment planning and design wizard. Its own status tip says it best. This button will automatically finish all the required planning and design. You could just enjoy your time and watch this to be finished. It stays disabled until the data is ready, then runs everything you're about to learn automatically. So why learn the manual flow? Because the manual flow is what AlignerBot automates. When the bot hands you a finished plan, your job becomes reviewing it. And you can only review staging, attachments, and arch decisions if you know the pages where they live and what good looks like. The rest of this lecture is learning to read what the bot writes. This is the environment for the rest of the lecture, the orthoplus desktop. Everything that follows happens on your own workstation. The compute is local, and every decision, segmentation boundaries, arch form, staging, attachments, is yours to inspect and override. That's the division of labor in the Cympha world. The cloud handles the case workflow, statuses, approvals, file movement, while the design engine does the heavy geometry in front of you. Keep the workflow toolbar in view as we go. Each step from here on is one of its pages in order. Step 1. On the data preparation page. Load plaster model is the upper input. Labeled upper jaw stone model or intraoral scan, the product telling you again that both sources are welcome. Then load lower jaw scan. If you have one, add additional bite scan, the input that enables rearticulating the case at a different bite position, the severe malocclusion workflow from the prerequisites. Optionally, round out the record, load facial scan, the face scan input, and add pictures for two-dimensional photos. Both are first-class case inputs that earn their keep in the final report. That's the whole page. Get every piece of patient data in now, so no later step waits on missing inputs. Step 2. Click Fix Models. It brings up the model fixing tools. Scan repair is its own named step before segmentation, for good reason. A clean mesh makes every later step better. All-in-one fix is the single-click starting point. Per its tooltip, it handles many surface artifacts and non-manifold geometries, and can even remove holes connecting the lingual and buccal side in the interproximal area, the classic intraoral skin defect. For most scanner output, that's all you need. When it isn't, the toolbox carries individual named operations organized into groups. Among them, mesh optimization, fill holes, remove non-manifold, plaster model skin cleanup, remove attachments or brackets, and smart fix. One tool deserves a special note. Reduce undercuts deliberately does not block out all undercuts, that would cause aligners to be too loose, it reduces the level of undercuts instead. That aligner fit thinking is baked in. Trust the default before overriding. One last piece of guidance on this page. Spend more time here only if the mesh has obvious artifacts. This isn't a step to perfect for its own sake. It's a step to get past. But don't skip it either, because a clean mesh makes every later step better. Step 3. The tooth segmentation page. The step to be patient with. Click Automatic Segmentation. The primary action. OrthoPlus separates the arch into individually addressed tooth meshes. If a single tooth comes out wrong, heavily restored, partially erupted, don't rerun the whole arch. The manual tooth segmentation group exists for this. Define tooth boundary. Segment tooth, then adjust tooth boundary on just that tooth. Change tooth number fixes a mislabel. Finish with the post-processing functions. Fix all for the jaw, smooth all boundary, optimize tooth orientations, fix interproximal areas, smooth current tooth boundary, one pass to clean boundaries across the jaw. While you work, the page shows a live Bolton index readout, an early sanity check on tooth size discrepancy. Why the extra minute here? Everything downstream, setup, staging, attachments, IPR, operates on these individually addressed teeth. Garbage segmentation cascades into a garbage plan. Step 4 begins in the initial treatment plan dialog, where the plan parameters live, split into an upper jaw plan and a lower jaw plan section. Plan range has exactly 4 options. All, 3 to 3, 4 to 4, 5 to 5. Sometimes it makes more sense to allow moving all the teeth. Sometimes it's better to move just some. The per jaw movement parameters are all editable. Protraction and retraction, expansion, extrusion and intrusion, the SPI curve, allowed IPR, and more. Automatic decision lets the system determine the major control parameters. And, a piece of honest UI design, it unchecks itself the moment you hand edit any value, so you always know whether you're on automatic or manual. And the dialog prints its own caveat. Some parameters, lower jaw extrusions, SPI curve height, are rough estimations, subject to various factors. Treat them as starting points, not promises. Then shape the arch and commit. In the dental arch setup section, fit the arch with the width and curvedness sliders. Per jaw, show arch curve displays the curves while you work. Spend real attention here. Too narrow or too wide is the most common mistake on this step, and behind most unnatural-looking setups. Next, drag the preview initial tooth setup slider. Its value is the percentage the teeth will likely be moved. 100% means all the way to the ideal arch curves. Scrub it and judge the setup with your own eyes before committing. When it reads right, click Finalize. OrthoPlus runs the collision and IP or adjustment and the SPI curve movement, locking in the final positions. The treatment goal is set. What remains is how the teeth get there. Staging. Step 5. Movement planning. Set upper steps and lower steps, per jaw, independently. Then click Automatic Staging. It reruns all tooth movements, adjusts positions mid-simulation so every collision is eliminated, and sets key frames for each tooth, rendered as red text in the movement table. Expect calmly that some steps may be added to the plan. That's the stager resolving collisions, not a bug. Review the added steps rather than deleting them. Movement limits are governed by name profiles in the System Settings dialog. Regular, substantial translations, substantial rotations, substantial translations and rotations, and minor movements, with per step and total limits underneath. Pick the profile that matches the case. Edit individual limits only when you know why. Review by playing the case. Playback movements, or playback movements with soft tissues to watch the gingiva follow. And if something reads wrong from a step onward, you don't restart. Plan from step replans from an arbitrary step forward. Step 6 is short to describe and worth slowing down for. Click Automatic Attachments. In the tool's own words, the system will automatically determine which teeth need attachments or force ridges, also known as power ridges, what kind, and how big they should be. It has a full set of criteria for the initial decisions, but you can always add, delete, or modify the attachments or force ridges. Read that the way the product means it. The automatic pass is a starting point, not a verdict. Go through the placements tooth by tooth, where the criteria match your clinical judgment. Move on, where they don't, change it. The button does the bookkeeping. The clinical responsibility stays with the person reviewing. Step 7. The aligner or model design page. The key decision is output type. Leave the default for arch models for thermoforming, the physical models you form aligner sheets over. or tick with aligner/retainer files to create aligner or retainer models for direct printing instead. Then generate. Generate upper models, generate lower models, or generate all models over an explicit step range if you don't want everything at once. 2 finishing touches. Add or update case tag places the case name and step number on the models, so printed parts stay identifiable on a bench full of arches. And the review design section lets you step through the generated arch models, trimming paths, and aligner models, and edit them before anything leaves the workstation. Generation isn't the end of judgment. It's the last place to apply it cheaply. Step 8. Saving and knowing which file does which job. 3 artifacts matter, and they are not interchangeable. The GOS file is the project, orthoplus's native format. 1 stable file per case, saved and reopened across sessions. It stays on the workstation. It is not the thing you upload. The GVW file is the plan review export, lightweight, made for the doctor to open in Cympha Studio and inspect the stage plan in the browser. And the Save for Transfer pack, the GPK, is the uploadable deliverable, the whole project pack for transfer, produced when a design phase is complete. Keep them straight this way. The project file is for you, the review file is for the doctor's eyes, and the transfer pack is for the case. How the deliverables reach the case defines how much clicking your lab does. Road 1. The Cympha Agent Manager, the unattended path. If your case folder is the one the agent manages, a review file arriving through the agent on a case and designing automatically flips it to awaiting approval with the planned step and emails the doctor. No lab click involved. A transfer pack arriving through the agent on a liner case at approved or changes requested fires the appliance approval the same way. Save into the watched folder, and the workflow advances itself. Road 2. The browser. You can upload either file on the case page at app.cympha.com, but browser uploads never auto-trigger approval. The case waits until someone on the lab side clicks Request Approval, a vetting step for when a human wants eyes on the files first. Unattended speed or manual control, your lab picks per case. Close the loop by knowing what happens on the other side. The doctor reviews on the case's approved page. Approval on the plan step sends the case back to designing for the appliance cycle, your phase 2 work. Approval on the final cycle delivers the case. And one rule that matters on AlignerBot cases: if the doctor wants changes, they must attach a structured revision artifact, an XML tooth position file exported from Cympha Studio's 3D review, or a transfer pack. Free text change requests can't be applied to the planner. The automation needs data it can act on, not prose. So when a doctor asks how to request a change on a bot case, adjust the teeth in Studio's review and export the revision, or send a pack, not a paragraph. The 5 most common sticking points. Automatic segmentation puts a boundary across the gum line on one tooth. Fix that tooth with the manual tools. Define tooth boundary, segment tooth, adjust tooth boundary, and leave the arch alone. The finalized setup looks unnatural. The arch curve is the culprit most of the time. Refit width and curvedness, scrub the preview, finalize again. Staging added steps you didn't ask for. That's collision elimination, keeping every movement feasible. Review the added steps rather than deleting them. You saved your deliverable, but the case on Cympha didn't move. Check the Agent Manager tray icon is paired, and the file is inside the agent's monitored case folder. Files saved elsewhere aren't seen, and only agent-delivered files auto-trigger approval. A browser upload waits for a manual request approval. Activation expired mid-setup. Codes last 10 minutes, and activate one machine. Generate a fresh one and paste it in. That's the full arc. Scans in on data preparation, a repaired and segmented arch, a setup you shaped and previewed before committing, staging that resolves its own collisions, attachments you reviewed tooth by tooth, generated models with your case tag on them, and 3 files that each know their job. The first case is slow because the pages are new. The 10th is fast because they aren't. And when you let the AlignerBot button do all of this automatically, you'll now know exactly how to read and where to correct what it hands you. Everything from today, every page name, dialogue, and file type is written down at cympha.com. Open the doc section and find Use OrthoPlus, your first clear aligner case end-to-end. If this series is helping, subscribe. We're walking through every Cympha workflow, one lecture at a time. Thanks for watching, and see you in the next one.